Hello everyone. In this video, we're going to be solving a logarithmic equation. But this is a non-standard type of log equation because we have log x and ln x. I know some folks are thinking, well, isn't log x the same as ln x? In this sense, I'm using base 10. When I write log x, I mean base 10. Because for base e, for natural log, I use ln. So they're distinguished. So this is non-standard because if you had ln x plus ln y, you could basically write it as ln xy, right? This is one of the properties of logarithms. And these days we're using those properties a lot. I don't know if you noticed. But we don't have that luxury. We have different bases. So what are we going to do? So we're going to be looking at this equation from different perspectives. I would like to introduce a method and then kind of talk about the solution, how we can get the solution. There are different ways to write it. And I'm also going to be showing you a graph at the end. All right, so let's go ahead and get started. So I would like to do something like the following. I want to be able to express both of these using the same base, and change of base comes to the rescue. What is change of base? If you have log of a with base b, then you can write it as log a over log b in any base, including base 10, including the natural log. So we can write this as ln a over ln b as well. So using that, even though this equation looks like, how am I going to combine these, right? Log x plus ln x do not combine. As is, yes. But if you turn the log x into ln x something, then you'll be able to combine them. So here's what we're going to do. We're going to write log x with base 10, of course, as ln x over ln 10. This is the critical step in solving this equation. Now, once you make this conversion, you're going to be able to solve this equation very easily. But we'll do a lot of algebraic manipulations here. We're going to use the properties of logs. We'll use e as a base, so on and so forth. So bear with me while I do that. And I will also show you a graph at the end. So let's go ahead and substitute this into our original equation. See what we get from there. ln x over ln 10 plus ln x equals 1. And again, this is not like the property where we condense logs, but more like, hey, I got the ln x twice, so I can factor it out. But let's go ahead and make a common denominator first. So I can multiply ln x by ln 10, so kind of like ln 10 times ln x. That is divided by ln 10 equals 1. I can cross multiply ln x and, let's not say and, I don't want to do two steps at once, so let me take my time here. And now we're going to factor out ln x. We factor out ln x. We get 1 plus ln 10 equals ln 10. Great. So now, from here we can isolate ln x. That gives us ln 10 over 1 plus ln 10. And now we're trying to solve for x, remember? But this is ln x. So how can I get x from here? I can do e to the power both sides, right? So from here, x equals e to the power ln 10 over 1 plus ln 10. Awesome. Now, what is this value? What is ln 10 divided by 1 plus ln 10? So approximately, this is the x value we get from e to the power ln 10 over 1 plus ln 10. Now, is there another way to approach this problem? So we got the solution by changing bases, and then we got the answer. So let's go ahead and take a look at the equation from another perspective. We have log x plus ln x equals 1. Now, I would like to do the following. I want to set, so here's what I would like to do. I want to isolate ln x and write this as 1 minus log x, and then set both of these equal to y. So from here, I get ln x equals y, and from here, x equals e to the power y. And then by replacing, let's see, 1 minus log x equals y gives me log x equals 1 minus y. And from here, I get x equals 10 to the power 1 minus I, because the base is 10 here and the base is e here. So now we got two different values for x. Let's go ahead and set them equal to each other. So this gives us e to the power y equals 10 to the power 1 minus y, which can be written as 10 over 10 to the power y. Let's go ahead and cross multiply. 10 to the y, e to the y equals 10. Now I can write this with the same exponent, 10e quantity to the power y equals 10. And at this point, I can definitely ln both sides and try to solve for the solution. But let's go ahead and log both sides just for fun, because I'll show you something. When I log both sides, obviously I get a 1 on the right hand side, which is great. And I'm going to move the y to the front. From here, y times log 10e becomes 1. And now y can be written as 1 over log 10e. But log 10e can be written as log 10 plus log e. And log 10 is the same as 1. So y can be written as 1 over 1 plus log e. So that could also work for y. But what is y? Y is... Wait, y is nothing. Y is ln x. Yay. Okay. Ln x is equal to y. So this is ln x, which means x can be written as e to the power 1 over 1 plus log e. Again, when I write log, it's base 10. Wait, I didn't get that answer first. I had a different answer using the first method, right? It was e to the power ln 10 over 1 plus ln 10. So why are they different? Let's go ahead and talk about it, and then I'm going to show you the graph and see how we can approach it from a graphical perspective. So this equation gave me e to the power ln 10. Let's take a look at that. E to the power ln 10 over 1 plus ln 10. Now here's the thing. I can basically write this as e to the power ln 10 to the power something, right? Like this. 1 over that. And I just want to tell you, e to the power ln y is always y, or e to the power ln z is z. So this just becomes 10, right? 10 to the power 1 over 1 plus ln 10. But you might still be thinking, why are they still different? Because the bases are different. If you wanted to change the bases, you can kind of change the bases, write the ln 10, or you can change, this is probably easier, write the log e as ln e over ln 10, which means 1 over ln 10, and then you're going to notice that it's going to turn into this one. Okay, cool. So that is basically how you can turn one of these into another, but doesn't matter, they're all valid solutions. Okay, let's go ahead and take a look at the graph now and see what the graph tells us. So for this purpose, I graphed these functions. So our original problem was, remember, ln x plus log x equals 1. I just subtracted log x from both sides and isolated the ln. As you know, ln x is an increasing function. Log x is very similar to ln x because it's just a multiple of it, right? Log x is also increasing. Negative log x is decreasing. So 1 minus log x is negative log x plus 1 is also a decreasing function. So we have an increasing function and a decreasing function, and they will intersect at a single point. And that point is given by the coordinates. You can see them. The x value is e to the power ln 10 over 1 plus ln 10. Of course, if you replace e to the power ln 10 with 10, you can get a different version of the solution, and pretty much, not pretty much, but it's basically going to give you the solutions. All right? This brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.